Hi students, welcome to my channel Thoughts of Physics. In the video series of wave optics, in this class I am going to explain wavefront and types of wavefront and Huygens principle. First, what is wavefront? The locus of all points vibrating in the same phase is called wavefront. Now let us consider a stone is thrown into the pond of water. Now the water surface gets disturbed and the disturbance spread out in all directions in the form of concentric cycles. Like this is a point of disturbance on the water surface. From this point of disturbance, the disturbance spread out in all directions like concentric circles like this. The disturbance spread out in all directions like concentric circles like this. Now, if you take each and every circle, the points on that circle, these are the points. Let us consider these are the points on that circle. All these points have the same phase of vibration. All these points have the same phase of vibration. That is, this circle is the locus of the points having the same phase. This circle can be considered as the locus of the points vibrating with the same phase. So, this circle can be considered as a wavefront. The definition of wavefront is the locus of all points vibrating in the same phase. So, this circle is the locus of the points vibrating in the same phase. If you take another circle also, if you consider some points on the another circle, these points also having same phase. So, the another circle also another wavefront. So, finally the wavefront is the locus of all points vibrating in the same phase is called wavefront. There are different types of wavefronts: spherical wavefront, cylindrical wavefront and plane wavefront. So, point source is the source of spherical wavefront and linear source like a slit is the source of cylindrical wavefront, and at large distance a small portion of spherical or cylindrical wavefront can be considered as a plane wavefront. Plane wavefront is not like a spherical and cylindrical. A small portion of spherical and cylindrical wavefront at long distance, at a large distance, it can be considered as plane wavefront. The energy of a wave travels in a direction perpendicular to the wavefront. Already we know the definition of a light ray. The straight line along which the light travels is called a ray. Here, the energy of a wave travels in a direction perpendicular to the wavefront. The direction along which the light or the energy travels is a ray. That means a ray is a line perpendicular to the wavefront. A ray is a line perpendicular to the wavefront. That is, the angle between a ray and wavefront is 90 degrees. So, Huygens principle. Now, Huygens principle is a geometrical method of finding the shape and position of a wavefront at some instant from the known shape and position of the wavefront at some earlier time. That means, if we know the shape and position of wavefront at some earlier time, we can determine the shape and position of the wavefront at some later time. That means it is a geometrical method of finding the shape and position of the wavefront at some instant of time from the known shape and position of the wavefront at some earlier time. That is the importance of this Huygens principle. Why we use Huygens principle? Next, what is the statement of Huygens principle? So the statement is, each point on a wavefront is a source of secondary disturbance, and the secondary wavelets originating from these points spread in all directions with the speed of the wave. Right. This is the statement of Huygens principle. Right. So already we have discussed that this Huygens principle is used to find the shape and position of the wavefront at some instant of time. Then how to find the shape and position of the wavefront? Right. The new wavefront at any later time can be obtained by taking the tangential surface in the forward direction to all the spheres of secondary wavelets. So let us discuss this point. That is, for example, let us consider it is a point source. Already in case of the wavefront concept, we have discussed that point source is the source of spherical wavefront. Point source is the source of spherical wavefront. Let us consider from this source, okay, there is a wavefront. This is the spherical wavefront. Let us consider from this point source, there is a spherical wavefront is originating. Right. According to Huygens principle, each point on the wavefront is a source of secondary disturbance. Now let us consider some points on the wavefront. These are the points on the wavefront. According to Huygens principle, each point on the wavefront is a source of secondary disturbance. Each and every point on this wavefront acts as the source of secondary disturbance. That means from these points, secondary disturbances are produced, secondary wavelets are produced, and these wavelets spread out in all directions with the speed of the wave. Now, how to find the shape and position of the new wavefront? So this is, let us consider AB, the wavefront AB. AB is the wavefront at earlier time. Now we are going to find the position and shape of the wavefront at some later time. For finding that, the new wavefront at any later time can be obtained by taking the tangential surface in the forward direction all the spheres of secondary wavelets. First, what are these spheres? Means all the points on the spherical wavefront acts as the source of secondary disturbance. Let us consider V is the speed of the wave in this medium. V is the speed of the wave in this medium, and in a time t, the disturbance spread in the form of a sphere of radius Vt. That means, so each and every point, that point means it is the source of secondary disturbance. That means from this it spread like this, like a sphere. The radius of this sphere is Vt, where V is the speed of the wave in this medium and T is the time. In the time T, it formed in the form of a circle. Similarly, this point also spread out in the form of a circle, like this. Now here from this also it spread in the form of a circle like this. Now these are the spheres for all the secondary disturbance. So these are the spheres of the points. Now how the new wavefront can be obtained at any later time is by taking the tangential surface in the forward direction. This is the forward direction. By taking the tangential surface in the forward direction, all the spheres of secondary wavelets. These are the spheres of the secondary wavelets. By taking the tangential surface in the forward direction. Now, let us take the tangential surface. So, this is the tangential surface. So, this is the tangential surface for these spheres of the secondary wavelets. Now, this is the position of the new wavefront. Now, CD is the position of the new wave. Like this, the new wavefront can be obtained at any later time by taking the tangential surface in the forward direction to all spheres of secondary wavelets. If you have any doubts, you can ask in the comment section. For latest updates, subscribe and click the bell icon. Thank you.